We good? No, just messing around. Does that look like stairs? That
Yeah,
did
look like stairs.
Fantastic. Right. So I'm going through with you guys, but this is also for you in the camera. We're going to go through Unit 2. So we've already done Unit 1 of the exam. Today is June 2012, Unit 2. It's worth, again, another 60 marks. So Unit 1 was worth 60 marks. Unit 2 is worth 60 marks. Unit 3 is worth 80. And remember, you combine the 3 units together out of 200 to get to where you need to be. And that's what will give you your final mark in mathematics. So today is looking at Unit 2. The last exam we looked at, Unit 1, was probability and statistics. Today it's number, algebra and geometry. Anything that was on a pink cue card will not be in this exam. Cool? Alright. The exam here is again structured in the exact same order as what the test paper for June 2012 will be. The questions are in the same order. The skills and content are slightly different, so that I'm not just giving you the exam questions wherever possible. In some cases I've had to use the same questions though. So we're going to go through this and we're going to start. The first question that comes up is angles in parallel lines. So when we see parallel lines, can anyone remember the 3 rules that we need to think of when we think parallel lines? 3 rules, 3 shapes, 3 letters that are linked to it. Z, yes. Alternate angles. So it looks like this. F angles, yes. So it looks like this. And there's a C shape as well. Now, those 3 rules are important. The first one here is alternate angles. And alternate angles are equal. You make sure you're putting these, just 3 little keys, remember. Today is all about getting down and getting the keys down, the clues down that are going to help you be able to do the exam paper or this practice exam tomorrow or next lesson. Corresponding angles are equal. And the last one is interior angles. Are they equal? No. Interior angles add to 180 degrees. So you've got those 3 rules and 3 facts that you need to remember. You're on camera.
Oh yeah, that's the bad thing. I'm taking these as well.
I apologise, you can't get good help, it's ridiculous. Anyway, so let's carry on. So having a look at this, we've got parallel lines, so we know we're going to do a parallel line type question, and as soon as we see those parallel lines, we're going to start working out how we can get to the final answer. In this case, it's really simple. In this case, I can work out this missing angle here, because I have angles on a straight line, which add to 180. So I can work this one out as being 30 degrees. And once I've done that, I can have a look, and I've got a parallel line here, a parallel line here, and I can see I've got Z angles here. Which means I'd sit there and I'd say, okay, then my final answer is that X is 30 degrees because alternate angles are equal. Don't copy down the solution, copy down those notes, look at this, have a look at how I went about doing it and the process. You're doing this next time you look at this paper, not now. So don't do the answers on there just yet. Just take the notes you need. So those 3 rules are what we're looking at as soon as we see an angle problem with parallel lines. Any questions? Nope. And if you're on the camera, you don't get a question. Tough. All right. I told you to talk to it. I can't help myself. So that's the first question. Second question is nth term. What is nth term? What is it talking about? Really, miss?
Where are the X-band papers?
Really?
You've hid them underneath your jacket.
I have, they're just here. Oh, yeah. Playing up for the camera, what's that about? Alright, so let's have a look. Nth term. It's just a way of writing a little bit of algebra to describe a pattern. So help me out. What's the pattern in this first one?
5.
5.
10.
So what's the pattern? Be a bit more descriptive than just 5.
And plus 5.
You're up with the plus 5. Why did you say plus 5?
Because it's plus and 5 every time.
So you said plus 5. So what we've got there is we're adding 5 on each time. You're right, we're adding on 5 each time. What that does is that 5 is going up in multiples of 5. So actually, what that is that's 5n. That's the bit that goes with the n for the nth term, 5n. So because it's going up in lots of 5, it's 5n. And when I go back one, what would it be? 0, nothing. So what I end up with is the nth term, the rule for that pattern is 5n. That's it. And have a look at it. The first term, term number 1, n is 1. 5 times 1 is 5. Term number 2, 5 times 2 is 10. Term number 3, 5 times 3 is 15. Term number 4, 5 times 4 would give me 20. So this here now describes, or helps me find, each of the values of a term number. So if I want a term 100, for instance, it would be 5 times 100, which would be 500. So rather than having to count along 500 bits, I know that actually 5 times 100 for this nth term gives me 500. So that's the 500th term in the sequence. And I can do the same for these ones. So let's go really quickly. Again, you're not copying down the answers, you're just copying down a note. So the note for this is look for what the pattern is changing by. That's what goes with the n. And then you go back to this, this happens to be 0, you go back to the term just before this and find out what it is, and that's what you plus or minus. In that case it was nothing. In this case, it's going up by how much?
3.
So up by 3, 3, 3, so there's my pattern, it's 3n. So it's going to be 3n. And then when I go back it becomes what? 2, positive 2 or negative 2? Positive 2, so I end up with 3n, goes up by 3 each time, 3n, and then positive 2, plus 2. And I can check that. Let's check with the 1, 2, 3, 4th term. So 3 times 4 is 12, plus 2 is 14. The 4th term is 14. So the n is talking about what term number. You match it up in that way. The last one, going up in, what are we going up by? 7s. So it'll be 7n. And then here we go back and we end up with minus 6 because we've gone back, what, 7? Minus 6, so you end up with 7n minus 6. If this was going down by 7, what would I have written there instead? So instead of going up by 7s, it was going down by 7s. Instead of being a positive 7n, it would be a minus 7n. It's that simple. And that's patterns. So again, don't write the answer down. Just take notes here so you can sit there and you can remember that this is happening. You go back to the term before it. And here, this n goes with this bit that's changing. And it's a real common mistake to make that if you're not careful on that. Really quickly, a ratio question. So when we have a look at the ratio question, it's talking about parts, it's talking about dividing it. This is a non-calculator paper, don't forget that. So having a look here, 240 pounds shared between Alice and Bill in the ratio of 5 to 3. How many parts is that in total then? 8 parts. Alice gets 5 parts. Bill gets 3 parts. It's really important to have a look at the fact that Alice, Bill, 5, 3. So the order that the names are written in is the same order the ratio is in. So in this case, you end up with 5 to 3 means I've got 8 parts in total. 8 parts. So I take 240 pounds. And I say 1 part is 240 divided by 8, which is 30. Sorry, Miss. Don't worry. It's just Miss Bersham ruining the lesson again.
Hey, Miss, sorry, sir, we've just got a paper missing. Esther's pink paper. And I seem to think it might be in here somewhere.
I did see it.
There's one under there.
Wrong camera. I told you, ruining the lesson again, as always.
Sorry.
We're recording the lesson. Yeah, that's why I'm weirdly looking at. Hi. Yeah. Okay, let's carry on. 8 parts is 240, which means 1 part, that 240 divided into 8 equal parts is 30 pounds. And then I can just work out how much Alice gets. Alice gets 5 parts. 5 times 30 is 150. And Bill gets 3 parts. 3 times 30 gives me 90. The 5 parts, 150, plus the 3 parts, 90, means I have a total of 240 pounds. So that's right. And so the difference, you can see there, was 60 pounds. Done. So it's actually the unitary method. It works in a similar way to what we do percentages. In percentages, I divide by 100 to get 1%. In this case, I divide by 8 to get 1 part. And once I've got 1 part, it's easy to find however much I'm after. So ratios are the same as percentages. In this question, if you share out 60 pounds between Alice and Bill in the ratio 2 to 3, how much does each of them get? Well, there's 5 parts in total. One part is 60 divided by 5, which is 12. And then you can calculate 2 parts for Alice by doubling that, and 3 parts for Bill by tripling it. But I'll leave that for you. Make sure you've got the notes down so that what you can do is you can do this in the next lesson, this skill. Next question. Oh, that's exhausting. Oh, you guys must be so happy that you don't have to watch this like the other people tomorrow. Sorry. All right. Operations with fractions. You need to be able to do this. We did this. If you remember, we did it way back when. We had a look at making sure that these are like fractions first. Multiplying is easy and dividing is just multiplying with a step added before it. That's all you have to remember. So we started off up here and we said we need to cross multiply. Cross multiplying means we had 3 times 3 and 3 times 2. 3 times 3 and 3 times 2. So 2/3 is the same as 6/9. And on the other side, what a goose. Ignore that. That was garbage. Alright. Cross multiply, but don't be a clown and do it the right way. 8 times 2 and 8 times 3. We're cross multiplying the denominators, not the numerators. 8 times 2 is 16, and 8 times 3 is 24. Then we cross multiply the other way. 3 times 3 and 3 times 8 is 9 over 24. You'll know if you've got it right because they'll both be 24. One of them won't be 9 like some clown tried to do. So you'll get it right. And then once you've done that, the rest of the question's really easy. The rest of the question is just if I've got 16 24ths plus 9 24ths, add the two together, I get 25 over 24. Simplified is what? How many times does 24 go into 25? Once. With how many left over? With 1 out of 24 left. And that's it. I'm not going to do this because it's the same. I am going to do this because it's dead easy and I like doing them. When it's multiplying, be careful in the exam. They'll give you a multiplying question, sometimes around an addition question. See if you mix up the skills, because multiplying is much, much easier. 3 times 8 is 24. 4 times 9 is 36. Done. I could simplify it because they're both even numbers. So that could be, what, half both of them? Could I simplify that any further? Let's just keep going. It's easier for even numbers because I can just keep halving it, can't I? 6 over 9. They're not both even numbers, so I can't halve them anymore. What could I do? Yeah, divide them both by 3. They are both factors of 3. Sorry, multiples of 3. Oh my goodness, what a great day. So I divide 6 by 3 is 2, 9 by 3 is 3, and this is disaster. I'm really glad this is recording. When we divide down the bottom, I don't ever do a division. What do we multiply? It's a funny word, do you remember it? Instead of a division, we multiply by the, starts with an R, rhymes with reciprocal. Reciprocal, fantastic. So 2/3 times by 6 over 1. The reciprocal means I just invert that fraction. So I swap it over. And then it's exactly the same as this skill. 2 times 6, 3 times 1. I'm not going to go through that because we've just done the multiplication. I'm saying it's exactly the same as this skill. So instead of doing a division of fractions, instead of dividing, we multiply by the reciprocal. And that's how we do a question like that. And yes, bonus. I got the 2 questions that I did right. Yay me! Percentage increase and decrease means that we're not just calculating a percentage of an amount, we're then either adding it on or taking it away, which is more likely the way that you need to do things in real life. You normally get a 20% discount, or you have to pay 20% VAT. So when we have a look here, this question, price of a pair of shoes is £75. How much are they after a price increase of 10%? How do I find 10%?
Divide by 10.
Divide by 10, yeah? Can I divide by 100 times by 10? Why wouldn't I on this particular paper?
Calculator.
Because it's a non-calculator paper, so I need to know my non-calculator methods as well. So to find 10%, I just divide it by 10. If I wanted to find 5%, what would I do with that 10%? Halve it. If I wanted to find 2.5%, what would I do with the 5%? Halve it. If I wanted to find 7.5%, I take my 5%, my 2.5%, and I add it together. So what we've got there is, in this case it's easy, it's just 10%. So 10% of £75 equals £7.50. It's an increase. So what am I going to do with the £7.50? Add it on. That's it. Percentage increase, decrease. Work out what the percentage is and either add it or subtract it. So you get £82.50 in this one. Calculate 15% and take it away. So I'd calculate 10%. Half of that is 5%. Add the two together for 15%. And then take it off there. And you're not with it. So it's going to be 1,200. Yeah? Okay. Make your notes again. So you can do this next lesson. We did an extensive part on expanding. We talked about canoes and we talked about waves and we talked about all that sort of stuff. You need to be thinking in this one, in these particular questions, which is this question coming up on that part of the exam, you need to be thinking about what? It looks like a canoe. What happens when the wave hits it? What gets wet?
Everything inside the bracket.
Everything inside the bracket. So what do you need to do with that 4?
Times it by the x.
Is that all? Just times it by the x. Times it by the x, times it by the 5. Multiply everything inside the bracket by the number at the front. So in this case, 4 times x is 4x. 4 times 5 is 20. In this case, why is this part more difficult?
Negative.
Because it's got the negative, which we just make sure we include the negative as a part of that number. 3 times x is positive 3x. And 3 times minus 6 is what? 3 times 6 is 18, so 3 times minus 6 is minus 18. And then I put it together, 4x, positive 4x, plus 20, plus 3x, minus 18, just taking them exactly and putting them into an expression. What am I going to do next? Simplify. 4x's plus 3x gives me 7x, and then positive 20 minus 18 gives me a positive 2. 7x plus 2, that's it. It's that simple. It's really just dealing with very simple terms and some term calculations. Break it down into the simple steps. Don't look at it as one big, massive, difficult question. I'll leave this second one for you to do because, again, it's the same thing. Be careful, though, here. That's a -2. When we're multiplying negatives, you need to just beware. So take care on that. Again, put down any keynotes. I'd suggest that a keynote there would be canoes and waves, and make sure you remember it. Yeah, got it right again. On fire. All right. Factorise is the exact opposite of canoes and waves. Factorise is looking at the question, taking it and putting it back into a bracket. So in this particular question, if we're going to put these back into brackets, well, we need to find factors. We need to find the highest common factor. So what's the highest number that divides into both 2 and 4 evenly? What number divides into number 2 and divides into number 4? What number is a factor of both of those?
8.
No. You're talking multiples. I'm saying what divides evenly into it?
2.
2, yeah. 2 times 1 and 2 times 2. So I've got 2. So I put it back in the brackets. So when I was doing my canoe and the wave, 2 times what would have given me 2x?
X.
Would have been an x in there. And 2 times what would have given me 4?
2.
Positive 2 or negative 2?
Positive.
That's it. That's factorising, that's all it is. I'm going to skip down. I'm going to do this ridiculous question. So my question again to you is exactly the same. In this case, what's the highest number that will divide evenly into both the number 3 and the number 9? 3. Why? Help me out. 3 times what?
1.
Yeah, and 3 times?
3.
Fine. Unlike the first one, this one has letter parts in both sides. So can you help me out? This is x squared is x times x, and there's just an x there. So what's the highest number of x's I could take out of each one of those terms? Could I take 2 x's out of here? Could I take an x and an x? I could. So I could take an x squared out, but do I have an x times an x over here? So I can just take a single x, because there's only a single x that's a common factor of both of those terms. So in here, I put an x. And what about with the y's?
Put y as well.
Yeah, a single y.
Bracket.
And then I sit there and say 3 times what? 3xy multiplied by what would give me x squared and y squared. So what was left here? When I took that x out, what was left? Just an x and a y. And then what about the second part? 3 times what gives me 9? 3. And was there an x and a y left? No, it's already 3xy. Times by 3 gives me 9xy. So that's it. I'm not going to say factorising is the easiest skill. It's kind of like dividing or subtracting. Adding numbers is pretty straightforward. Multiplying numbers is pretty straightforward. Expanding brackets is pretty straightforward. People tend to get held up on, if they can add, that's fine. Subtraction just doesn't work as well in our brain. And people can multiply quite well, but division doesn't work quite so well the way we work. It's the same for factorising brackets. It's a skill you need to be able to do, but it's something you're going to have to work on because it's just something that doesn't normally fit quite so easily. If I said to you 4 times 2, what is it?
8.
8 divided by 4?
2.
27 divided by 3?
9.
You're quite quick. Alright, apart from you, everyone else knows. Right, again, take those notes. Make sure you've got it there, make sure you know what you're doing. Can you just put down the factorise, opposite of expanding. It's the opposite of expanding, it's the act opposite. So the opposite of adding is subtracting, the opposite of multiplying is dividing, the opposite of expanding is factorising. This question I took straight out of the exam, so I took this straight out. I didn't have a great example, so this is the question you're going to come across in an exam. It's a simple build calculation. I suppose the catch on this one is that it's a non-calculator paper. So you're going to have to do all your calculations and work things out. So in the exam, you're going to look at this. Again, it's another one where you get actually quite a bit of information. You know what? I couldn't care less that CP Energy have the phrase, connecting people, connecting places. It's just information that's given to you, because actually that sort of stuff does go on bills, but you need to cut to the chase and you need to get to the important information. Just the same as the ferry question that we did in the last paper. So here, work out how much Joe has to pay for the unit she has used. Here's the readings, number of units used, cost per unit. What do I have to do in this question? Do I care how much she had at the start of January and how much she had at the start of April? Why?
It's not relevant.
It kind of is, but what have they given me to help me out?
Number of units used.
But,
Number of units used.
yeah, they've already given me how many units used, so if they wanted to make their question harder, I wouldn't have got that. I would have had to work out what the difference was between those two numbers. Subtract one away from the other on a non-calculator paper. But they haven't. Cha-ching, I'll take that. So all I need to do is I need to do 515, and for every unit she uses, she has to pay 35p. So what do I need to do?
Times it.
Times it, that's it. 35 times 515. Yeah? And then you go through and you do that multiplication. 5 times 5, 5 times 1, 5 times 5. Put down the 0, 3 times 5, 3 times 1, 3 times 5. Do the calculation out. I'm not going to sit here and go through the calculation with you now. If you don't know, you need to make sure you find out, because I'm telling you that question is going to be the question you're going to do in your test, and you're going to need to know how to do that skill. The only catch I'd say is if it's 35p, our answer is going to be in pence. How would I change that to pounds at the end of the question if I wanted to? Because we don't normally sit there and say you owe me 1,030 pence. What do you do? Not times by 100, divide by 100. There's 100 pence per pound, so you divide by 100. So 1,030, I'm not saying that's the answer to this question, but 1,030 pence is actually just £10.30, which then makes a lot more sense. Sounds right. So that question, you're looking at making sure you do those calculations correctly. This question, it's a 3D shape. It talks about surface area, not volume, surface area. Surface area we'll cut that out later. Surface area is just the area of each face or surface of the solid added together. And for this shape, it's really easy. If I wanted to challenge you in the exam, I'd probably give you the same question but with a triangular prism. I don't know. I'm just saying. If you wanted to make sure you practice ready for the exam you're going to do, then I'd think about a triangular prism. Triangular prism. Right, so on this particular one it's easy. What's the area of a rectangle? Come on guys.
What, that rectangle?
Any rectangle. What's the formula of a rectangle? Area for a rectangle? Base. Fantastic, so it's base times height. In this case it's 10 times 5, which is 50 centimetres squared. Lovely. What's a great property that I know about a cuboid, so save me having to do an extra calculation. The front face is going to be the same as which other face?
Back face.
The front and the back faces are going to be the same. So for a cuboid, that's easy. In fact, for a triangular prism, if I was going to do a triangular prism in an exam question, like you're going to do in your paper next, then the ends, those triangles on the ends are the same size, aren't they? What is the formula? Just in case I wanted to really remember it for my exam. What's the area formula of a triangle?
Base times height divided by 2.
Base times height divided by 2. Base times height, exactly the same as a rectangle or a square or a parallelogram or a rhombus, but you divide it by 2. So you don't need that for this question, but you might for your exam. So this one here, base times height, which is What's the base? 3 times by the height, which is 15 centimetres squared. Have I done all the sides yet? I've done the front and the back. I've done the left and the right.
Top and bottom.
The top and the bottom, which I'm not going to do for you. But you need to do base times height, calculate that. And then what I'd say is I'd say that's fine. You've then got 6 faces on the cuboid, 6 faces that you need to add together. You've got a 50 plus another 50 plus a 15 plus another 15 plus whatever the area of this rectangle is, the top, plus the area of the bottom, which is exactly the same. Add them all together. That's your final answer. That's the total surface area of the cuboid. The area of each individual shape added together. Any questions? And tough, you don't get any questions again. Don't mix the surface area up with volume. Volume is when you do the base times the height times the length. So it's the area of the cross section multiplied by the length. Volume is different to surface area. When I was playing around on the computer, I couldn't cover this up in any reasonable way. So what you've actually got is you've got the graph already drawn on there. Doesn't make any difference because actually that's the easy part. That's just plotting some points using a ruler and drawing a straight line. This Unit 2 will only ever be a straight line graph. Unit 3 will bring in a curved graph. We'll bring in like a quadratic graph or a cubic or something like that. But for Unit 2, this exam, you only end up with a graph that you have to plot that's a straight line. So what you've got here is, it's just simple substitution. So in this case, I've got y equals 2x take away 3. I'm trying to find these values here. 2x take away 3. Can I give you a couple of tips? On this question, you need to fill in this table first. It's always easier to start with positive numbers rather than trying to start with -1. It's easier to start with 4. So 2 times 4 is 8. Take away 3 is 5. Make sense? All I've done is I've got the 2x take away 3. 2 times a number, subtract 3. So in this case, 2 times 4 is 8. Take away 3 is 5. 2 times 3 is 6. Take away 3 is 3. 2 times 2 is 2. Take away 3 is -1. 2 times 2 is 4. Take away 3 is 1. 2 times 1 is 2. Take away 3. 2 take away 3. Think temperature. It's 2 degrees. It gets 3 degrees colder. Goes down to -1. Can anyone help me out with this one without even doing a calculation on it? Because I'm sick of calculating, and you don't have to. Once you get the pattern. What's the next one? Minus 3. Yeah, it's going down by 2 each time. Yeah, it goes down. Unit 2 will be a straight line graph, which means once you start getting the pattern of what that's changing by each time, then it's the same all the way through. So you just fill that graph out. So that's what you end up with. And then you plot those points. And if you have a look on the graph here, you end up with x is -1, y is -5. There's your first little cross. X is 0, y is -3. X is 1, y is -1. So x is 1, y, is -1. X is 2, y is 1, yes?
Robin said she needs to see Joe Harris.
Okay.
Reception.
Right. Oh, get out of the road! Get out of the road of the camera! Cheers, man. Again, we'll edit that out, don't worry. Alright. Any questions on that? So it's substitution, and that's all you need to do. And then you're sometimes asked to read a value of it. Same as what we've used to read any graph. So use your graph to work out the value of y when x is 2.5. So go to the x-axis, go to 2.5, read up until you hit the line, and across. And it's 2. It's that simple. So you're just reading off your graph based on what the value is you're given. And the second one's the same. So that one there, you won't be able to draw the graph. I would suggest it might be worth just drawing this out on a separate piece of paper and plotting the graph out, so you get that practice, but it's that simple, and that's what that question's going to be about. What question we have here? We've got much left? No? Excellent. We've got 15 minutes. Area of compound shapes. Area of compound shapes are easy. If I'm sitting here and I'm asking you to find the area of the triangle, how am I going to do that? So it's shapes we know. It's
That's not going to work.
Which two shapes can you see that we know there? And?
Square.
Square? Everyone see that? Or a rectangle? So you've got a rectangular triangle. If I wanted to work out the area of, say, the shaded sections, what would I do? I take the rectangle, and if I gave you a pair of scissors and a bit of paper, how would you get rid of this? You cut it out, you take it away. So, here, the area of a rectangle is base times height, which in this case is 12 times, or 11 times 12. Work that out. The area of the triangle is base times height divided by 2, which in this case is 11 times by the perpendicular height, which is 12, 11 times 12, and then half it. And then what you end up with is you end up with the area of a rectangle, the area of the triangle, and so to work the answer out, all you do is you subtract this away from what the total area was, as if you were cutting it away and throwing it out. Composite shapes or compound shapes in the exam will be made up of shapes you know, of rectangles, parallelograms, squares, and a rhombus, or triangles, or circles, or trapeziums. But that's what they'll be made up of. So if you can draw it using those shapes, it's likely to be in the exam as a compound shape. So all it's testing you really is that you know a couple of area formulas, and you can take one area away from the other and work out what gets cut away. Or if it's a shape that's built up, so like a house shape, so that, you'd work out the area of this, and you'd add them together instead, because you can see they've been added together, not one cut out of the other. So that's compound shapes. You probably want to make sure you put a note that base times height and base times height divided by 2 on that one, because you're going to need to make sure you don't forget those formula at all in the exam. Depreciation. I've got a tricky example here. If you get a depreciation question on the exam, it's likely, if it's on the non-calculator paper, that you're going to get a very simple percentage. So you'll be able to calculate it without a calculator. You might get 20%, or you might get 10%. 10% you divide by 10. 20% you divide by 10 and just double it for 20%. 2 tens is 20. So you do that. In this question, it's a little bit different. I'm going to just change that to 10% to show you it as a non-calculator skill, which is really easy. And I'm going to change this 3 years to 2 years for the sake of time. Okay? You may get asked this on Unit 3 or Unit 2. I can't guarantee which one. The complexity of the percentage will decide which exam paper it's on, whether it's on the non-calculator or calculator. So when we have a look here, what we end up with is Year 1. It's depreciation, so is it going up or down? Down. So Year 1, what I want to do is 10% of 14,600 is 1,460. Everyone agree? Yeah? And because it's depreciation, I need to take that away. So I started off with this much, 14,600, and I take away 10%, which leaves me, oh, that's awesome. Done. What is wrong with me? So it's been 13,140. Anyone do that differently? Like, rather than having to do a subtraction like that, can you give me a different method of being able to do that? You can start off with 14,600, take away 1,000, gives you 13,600. Take away 400, gives you 13,200. Take away another 60, gives you 13,140. That's that partitioning that we've spoken about before. So don't get stuck. If you all of a sudden in an exam get flustered and you're like, oh, I can't do subtraction, there's a whole range of different methods for doing it. Just think about partitioning. Take it off in chunks until you get down to where you are. Think about it on number lines. Don't let the fact that you don't have a calculator and you're doing a subtraction question, or an addition question for that matter, stump you and stop you from doing the skill. So we end up with 1,000 or 13,140. So year 2, we have 10% of the new amount is 1,314. And again, I'm going to take that away from here. In fact, what I will do, I'll do partitioning myself this time, yeah, to show you. So I start off with 1,000 or 13,140, and I'm going to take off 1,000 to start off with, 12,140. I'm going to take off 300, which goes back to 11,840. Yeah. I'm going to take off 10, 11,830, and then I'm going to take off another 4, 11,826. So don't get stuck if it's a tricky question with subtraction. Use a whole range of methods. That being said, being able to subtract is a good skill to be able to do, so you should make sure you practice it. Okay? And that's your final answer. That's how much you end up with. Notice in depreciation, what you do is you take off 10%, and then you have to recalculate what 10% is and take it off again from the new amount. You can't, and the common mistake is to work out this amount and then just take it off twice. And you can't do that. It changes year on year, as it does for compound interest or appreciation, where it's going up in value. So make sure you do that. So you have to calculate the percentage in this case. Well, in this case, you calculate 23% 3 times on 3 different values. Each time it's dropping by 23%. But that's a different amount year on year. Ooh, come on. Expand and simplify. Remember we talked about, do you remember the key word for this? Starts with a, come on, 4 letters.
Foil.
Foil. Yes. Foil. So here, what we do is we start off and we've got the first, x times x. The outer, which is a negative, I'm going to be careful of negatives, which is x times minus 2. The inner, which is 3 times x. And the last, which is 3 times minus 2. Foil, remember it makes that little face if you're worried about it. X times x is x squared. X times minus 2, well x times 2 would be 2x. So x times minus 2 is minus 2x. 3 times x is 3x. 3 times minus 2 is minus 6. Right amount, x squared, negative 2x, positive 3x, negative 6. Collect any like terms, x squared, negative 2 plus 3. If it's negative 2 degrees Celsius, pretty cold, gets 3 degrees warmer, what does it go up to? 1. So do I write 1x?
X.
Just x. Take away 6. Done. I'm not going to do the second one because I've just showed you the skill. But please write down foil, and please don't forget that once you've done that, it's just again dealing with small terms and calculations with those terms. Bit of multiplication, bit of addition. Foil. Oh my goodness, I'm going to have to speed up. Factorise, this is actually a difference of squares factorisation. So in this particular question, for the difference of squares, what we're looking at is we're looking at what's 2 numbers, what can I multiply together to get x squared?
X and
X and x. What can I multiply together to get 16? What can I square to get 16? 4. So all you do is you go x, 4, and what you end up with is a minus and a plus. Difference of squares. That's how you factorise that. Now, I'm going to be honest with you, you have to look for that pattern in a question. The factorisation question like this will be towards the end of the paper. It's definitely in the second half of the paper because it's a B grade skill. And when you're looking at it, you're looking to see whether or not you can go a times a is a squared, b times b is b squared, and there's a negative. Y times y is y squared, 3 times 3 is 9, and there's a negative. X times x is x squared, 1 times 1 is 1, and there's a negative. And as soon as that happens, you just put it in like that. x4, x4, a minus and a plus. AB, AB, a minus and a plus. Y3, Y3, a minus and a plus between them. So it ends up like this. X1, X1, a minus and a plus. That's it. That's difference of squares. You're looking for the pattern. Is that clear? Yeah? Be careful. Look for that. Before you start going and factorising, look and see whether or not you can spot that. Because if you can, it'll make the question much easier. And it's so simple to get marks on that. It's so simple to factorise when you know that you're looking for that little bit. I'm going to do this. Cuboid lies on coordinate axes. Now, with this is 3D coordinates. Now, goodness me. You guys have got, anyone here got a 3D TV? No? We've been to 3D and seen cinema in 3D. You know what it is. You know we've got our traditional x-axis and our y-axis. Now, normally when you're asked to draw graphs, like earlier, you're asked to draw on the x and the y. All 3D is it's got another one coming out off the page. So here, the way that they've drawn it on a bit of paper is to show that it's coming out. And I need you to think in 3D. And for a question like this, to think in 3D, you're going to be sitting there and you're going to be following and working in those 3 planes, either going across the page on the x-axis, up and down the page on the y-axis, or coming off the page towards yourself on the z-axis. And that, once you do that, you have a look, and let's look at this point. This is 5, 3, 4. X, Y, Z, alphabetical order. So, the X means I start here and I go across. So what's the coordinates, what is the position is that on the x-axis? Have a look at it. That plane there, although it looks like it's on an angle, is actually in 3D. So that's all flat. So it's going to be that point there. So it's going to be 5. Yeah? You look at it. That distance from there to there is the same as there to there. It's just being pulled out off the page a little bit, moved up. The 3 means that I go up the y-axis 3, because that's how high that is. And the 4 means I've come off the page 4. So I'll come out. Write down the coordinates of the point P. So the point P, I know that that's 5, 3, 4. The point P means I've gone back in which axis?
Z.
I've gone back in the z-axis, which is the 3rd coordinate. And to go back in line with this, I've gone back 4. So it'll be 5, 3, 0. And that's all you're going to do. You're going to pick a point and then trace it and change that coordinate by what you're tracing it by. So write down the coordinates of the point T here. So to go back there, I've got 5, 3, 0. And now I'm going to go down on the y-axis by how much? 3. So I've gone 5, 3, 0. Now I'm going to go down to 5, 0, 0. Because I lose that y coordinate. And just following it around on there. I'm going to probably stop because I'm looking at the time and it's time to finish. These last couple of questions, if I'm honest with you, we've still got some skills to cover in terms of the course. And these last couple of questions, don't pack up yet please. Don't pack up if you're on the video camera, I know you're thinking about it. These final questions are recurring decimals, rationalising the denominator, circle theorems, compound measures, perpendicular lines and coordinate graphs, and simplifying when you're going to have to factorise both the top and the bottom of a fractional, algebraic fractional term. So there's still quite a few skills for us to cover, but there's definitely enough on that for you to sit there and you to do, particularly if you're adding it to the fantastic marks that you got on that first paper. This is why it's really important. Remember, as we go through units, they do get harder, so you're going to need to make sure you build up every mark possible. Right guys, pack your stuff up please, and sit quietly. You too.